right. We should be up here just momentarily. And I will be getting started just as soon as I confirm that the stream transitioned over to me and that I am good to go. Looks like there's a little bit of buffering in here, so just bear with me a moment. Let me make sure this is all up and going. I'm going to go ahead and get started and just assume here that this is about a minute behind me in live time, because it looks like it is. All right, so let me get going here and get started. So let's talk a little bit today about the Swift package manager. So what I've done here is I've got my downloads folder. And hey, everybody out there watching, I'm glad you could join us. I am Ryan Collins. You can reach me on this perfect Slack channel at RYMCall, that's RYMCOL, or the same on Twitter. So what I've done is I've pre-prepared this to-do demo here. Let me just go ahead and expand it out so I have a fresh folder to work with. This is going to be very similar to what you would find online if you looked in perfect examples and you looked at the iOS demo and you looked at the API. The only difference is in this, it's already pre-split up, and in mine, I'm going to talk a little bit about the Swift package manager in general and how we do that. So the first thing you'll notice in here is that I had a build inside this folder, and of course that's not going to work real well for us because I built it somewhere else besides my downloads folder before I actually did this, so it'll give us all sorts of troubles. So I'm just going to go into my to-do demo here. And since we're talking about the Swift package manager, in Swift 3.1 there were a few changes. You can no longer do Swift build clean or clean equals dist to get rid of your sources. It's now Swift package clean or Swift package reset. So Swift package clean would be the equivalent of passing the clean flag, and reset would be the equivalent of passing that clean equals dist. And all that really does is it's going to delete the build artifacts and the repositories, which instead of your dependencies are no longer stored in packages, they're stored in the build folder under repositories, and they are pinned to different versions in package.pins. If you just look at basically package.pins, it's just a JSON list of the package name, whatever reason is, the repository's URL, and what version it is. And if you want to update those at any time, you can Swift package update to make sure that you have the latest sorts. We're just going to reset so that just goes away. So there's no build, there's no repositories in there anymore, and I'm just going to go ahead and delete that and run Swift build. So I should be able to get a clean build out of this one. So while that's running in the background, let me go and switch in here to presentation so we can all see. This is the very most basic I can make the package file for this particular API demo. Now this has a package, it has a name, and it has dependencies, and that's just it. In the sources, there's a main.swift, which makes this an executable, and then there's the files that it depends on, my routes, my model, and the things that work in between those to make the API work. So I've tried to keep this roughly as simple as I can here, so that we can go over what it takes to split that into multiple targets, why you might want to split into multiple targets, and all that fun stuff. So let me just wait until this is all compiled here. We should get a bunch of warnings, but we should get the linking and the build, which we do. Package, generate Xcode project. And for those of you out there who are used to perfect, there's a reason I'm not using perfect assistant in this one, because I want to really get you to know the package files and to see what they look like and splitting up in targets and how that works. So I am purposefully not using that today. Right, so here we have our Xcode project, and I should be able to pull that up. There are two targets that are generated from a Swift package, which are this guy right here, the framework looking guy, and the executable looking guy, which is what we run. You'll see in the sources folder, you have a parallel of what's in your sources folder here. The reason this has two targets, if you've never known, is because you run tests against this one as a framework and you run this one as the executable. Because of the way Swift Package Manager works with its tests being in a separate folder from sources and everything, Xcode kind of generates that so you can do that if you didn't know that. Out of habit, I usually use a custom working directory, which is my to-do demo. We'll probably end up generating this project a few different times. So what we can do here is, I'll skip that next time to save time, but it's just kind of a good habit to be in. So essentially I have this project set up like this. Main imports everything I need to run a perfect server. I'm using MySQL Storm. If I pull this up here, perfect testing. Basically it's a to-do API. It's split up into items, and then tokens and users comes from the pre-set up perfect turnstile MySQL, so that I didn't have to do the extra work to get authentication in with it. So what it does is it creates the server instance, it performs the make auth routes and make JSON auth routes so that we have our authentication API. It adds the auth routes to the server, it connects to my MySQL server. It does I'm using the Storm ORM in here, so it does all of its table setups to make sure that it has all the tables it needs to go in there, as well as an access token store for the authentication. It goes through the routes and makes sure that those that need to be authenticated are, and those that need to be excluded from authentication, such as registration, are. It adds the filters for authentication, it makes the server, and it starts the server after adding my main routes. I put my main routes off in their own file just because it cleans things up a little bit. To-do item is going to be the model that I'm using today, and that is MySQL Storm, and like I said, I'm just using that ORM to make life easy. To-do manager, it runs the actual SQL queries that make things happen, such as counting, creating, updating, all of those fun things, deleting a to-do item, grabbing a user. It actually runs the SQL queries. And then to-do items is just a struct called items that I have that kind of works in between the routes and the to-do manager so that I can abstract all the JSON from there, decoding and encoding, just because it makes it a lot cleaner. So I kind of have to-do manager that interacts between the database, to-do items that mitigates between the route, the JSON for the routes and what the database wants in the model, and then the routes interact with the server and the items the model. So it's a pretty simple setup. So from this point, what I would say is that we have decided as a programmer that this is the greatest to-do API ever. We want to set ourselves up for scaling, for success. We want to hire a team, have multiple people working on it. So what we really want to do is we want to split up our model into its own framework so we can eventually have a library of models that's built as a framework and just imported. We want to split up our to-do, our database stuff into its own framework of database interactions. And then we want to have independent executable targets for things like our API, things like our front-end website, and things that we might have a cron target that runs jobs in the background that cleans up expired things or expired tokens. There's a lot of things you can do with this. So how do we go about doing this? Well, let's go back over to our package file. So the first thing I'm going to do in my package file here is I'm going to explicitly define the target we have. So the target we have is just called to do. It's just in our sources. So what I would do to explicitly define a target is I would first go into my sources. I would put all of these in a folder called to do. And now I have a target here. So not very different from what we do before, but instead of having everything in sources, I'm going to have it in a folder called to do. Now this folder called to do has a main.swift, which makes it an executable target. Because when we're talking Swift package manager, if we put a main.swift in our folder, it's going to make it executable. And if we don't, it's going to make it a framework, just a shared code library that other things can use without actually running anything. So let's tell it what we did. So now we need a target, okay? And that's going to be there. And we added a target, whoops. So we have a target, and our target has a name, and that name is to do. So really, our target also has dependencies. Everything's going to share our main project dependencies. You don't ever have to put anything here. So I'm just going to put it in blank for now. Whoops, that's what I did. Haha, that actually goes here. So it's got a name, it's got dependencies, and we can have more than one of them. So if I want to make more targets, I'm obviously going to add more. So this is just an array of targets, and the targets each take 2 arguments, name and dependencies, which is just an array of dependencies. And those can be made of multiple things. We'll get into that. So if I save that, and we go back in here, and we Swift package clean, and we Swift build on the command line, it'll run through its build process. I'm just going to delete this Xcode project so we can regenerate it, and I'll show you what I'm talking about here with the target. This isn't going to change a whole lot for our project because I still only have a single target project. The only real difference here is that I've explicitly defined it. I've put it in its own folder, and I've said, hey, I have a target in here. My target is to do, and it has no additional dependencies from my project besides the main dependencies that we're used to filling out. So I can generate an Xcode project, and that's going to do its turning. It's going to load over here, and then we still have those same 2 schemes up here, the framework for running tests against and our actual executable that we've defined. And the only difference is now that there's an extra target defined, we have this to-do folder, and then our sources are inside of there. Still runs the same, still does the same to-do management and everything it does. So now we need to talk about what we're going to do next. Well, the first thing that I usually do when I'm splitting a project up is I'm going to split the model out into its own target. And that's because I usually, once I have the models defined, it's pretty rare for me to need to change them. So once they're built into their own framework, it's easy to pass them around. It's easy to go down to your products and take one of the build that model framework will be down here. You can even archive it if you're so inclined and code sign it and all that. And you can import it into your other projects like an iOS or a Mac app as a framework, which is really convenient when you are making an iOS target. Now, that's not 100% straightforward when you're using an ORM like Storm, just because it's not going to recognize Storm, but we're still going to split it up because that's the point of our Oh So Fun webinar. Now this stuff, speaking of Oh So Fun, I actually really do enjoy this just because this is where you get a little bit more advanced with the Swift package manager, and you start to see the real value in splitting up the targets, which I'll talk a little bit more about later. So how do we make a new target? Well, the first thing we do is we make a new folder, and I'm going to call this to do model, since that is what I said I was going to split up. And what am I going to do? Well, I'm going to copy to do item, and I am going to paste him in there. And then I'm going to go back to do, and I'm going to delete him because he's going to be off in his own target. I need to get rid of this Xcode project because we're going to have to delete it and regenerate it. And I'm going to go back over to here. So we added a new target. So what do we need to do? Well, we need to tell it we have a new target. And I named the folder to do model. So that's going to be to do model to match the folder name. And now we have one more little thing that we need to do. So because the model is going to be off on its own in its own framework, to-do is going to need to access that because the to-do manager has a to-do item and it needs to know what a to-do item is so that it can do things with that, just like everything else. So in our dependencies up here, we need to go and say that this is dependent on a target, which is dot target, which you can have a few different things under dependencies. So dot target is the way you express that I have a dependency that is a target of the same project, and all you got to do is give it its name. So this is going to be to-do model. So all I'm saying is that my to-do target here, and because it has a main.swift that'll be executable, is dependent on my model. It's pretty simple. Let's save that. Let's do our Swift package clean and our Swift build. And we'll give that a second to run through. And then we'll just regenerate the Xcode project. And now this build is actually going to fail, and there's a reason for that. There's an important reason for that, and it's one of those things where we're going to get into it in just a moment. But the gist of it is that this is where access keywords like public become really important. File private, private, public, and open are your access modifiers, and this is where you have to start really thinking about that in your code. If you've never had things in a framework or multiple targets before, this is going to be fun. All right, so let's generate an Xcode project, let that run through its thing real quick, and we'll go modify this project to be what we need it to be. So we still have our same two targets, but now this time, if you look in sources, there's to-do and to-do model, right? And if you look in products, there's going to be a to-do model.framework. So we've made a framework by not having a main.swift in our folder, and we've split this out. If we build this and run it and try to run it, it's going to yell at us. And you'll see why it's going to yell at us. I don't have anything in a web root or anything, so I shouldn't have to change the custom working directory. Derived data should be just fine for us. There we go. Use of unresolved identifier to-do item. So it doesn't know what a to-do item is because we're using that in a framework. We have to import it, to-do model. Okay? If we were to build that, it's actually still not going to know what a to-do item is. And that's for that reason I mentioned a moment ago, is that to-do item has no access modifier in front of the class, which means it is private to the framework. That is the default. If there's another file in this to-do model framework, we will be able to access it. If there isn't, then we will not be able to access it. So this is where you really have to start thinking about public. And if you've seen some of my other projects, you'll note that I put private in front of variables that need to be private because they need to be not accessible, okay? So that's where we really have to start thinking about this. This needs to know what other things accessing the framework can access. And in this case, it's everything I would have originally intended to be private to the project. This is now going to be public. All the functions are going to be public. All of the public and public. All right. That all needs to be public so that that class can be seen by our routes and our manager. That's variables. When I say in here that I'm talking about a due date or something else, that we can actually see the to-do item and its dates and all that kind of fun stuff. Otherwise, none of this would work. So now that I've added those access modifiers, this project should just about build. Oh yes. Aha, of course it doesn't, because the other two need to import our to-do model. So our items needs to see the model, and our manager needs to see the model because they're both going to be working with to-do items. So there's the build succeeding. So that's pretty much the simplest form of splitting it. Our server's running, our API's working, and for the sake of this demo, you don't need to know that we don't need to mess with the API routes and know it's working. This is only about getting your project split up. Otherwise, I would be droning on for hours. So we've actually got our public modifiers This can now see it. We've successfully got 2. And this is where I'm saying, if you weren't using the ORM and your model was just as simple as it could be, this is where we could go and we could look at this is obviously the debug build, but you could actually take this framework, you could drag it and drop it into your iOS project, and you could use it. And that becomes really fun with sharing models, saves a lot of time for me on some of my projects that do that, and other things. The other thing that we're going to talk about is the fact that this makes scaling a little bit easier. You know, your models don't change very often, so having them in a framework is going to make your builds faster, and it's going to make it easier to stop and restart different portions of your project without having to go in and stop the whole thing. So what I mean by that is if you have an API and a website, and these are different targets, and maybe you even have a cron that runs in the background that's a different target, you can stop and start those independently. You can work on them independently and rebuild them independently. So the website can always stay live while the API goes down, rebuilds, and comes back online. The same goes for the website. If you take the web front end down, you don't necessarily have to take down your API or the cron jobs you have running. If you want to change or add cron jobs or change the way things are moving around in the background, you can stop and start that without killing your API or your website, which is pretty cool. And it also helps when multiple people are working on things. One can work on the API and it doesn't necessarily affect anything that anyone else is doing. So how would I go further with this? Well, I would break out the to-do manager into its own target, because if we have a website, well, that's going to be different from the API, and it's going to be different from the purpose of the API. The website's still going to need to interact with the database, but it's not necessarily going to need the to-do items or these particular routes to work. This makes my code cleaner. It makes the API just sandbox down to just the API routes. I don't have to think about which routes are for the API and which routes are for web views if I split those into multiple targets. So let's go ahead and do that as well. Okay, so I'm going to stop this, delete this, go back into sources. Let's add to-do manager. And that is, like I said, just the access for the API. I'm going to copy that file, paste it into there to make a framework. Whoops. We're going to go back into to-do, get rid of the manager. Going to go back into the project. Now we have 3 targets, so we need to tell our project that we have 3 targets. So I'm going to have another target here. And I'm just going to paste that in and call this manager. And the manager relies on the model, but now we also have to add another .target up here, because our API is going to rely on both the manager and the model. So to do manager. Cool. So we have a model, we have a manager that interacts with the database, and that relies on the model because it needs to know what a to-do item is. And then we have a to-do, and I could actually go even a little bit further and rename this to API. So we have a project name to-do, we have a target name to-do API. The to-do API relies on the model and the manager. The manager relies on the model, and the model's off all by itself. I want to make typos in there. Now, if we were to clean and build, we're going to get more build errors, and that's for the same reason last time, that the to-do manager doesn't have public. It's not a public struct, it's an it isn't public, so outside of this target, nothing can see it. So we can go ahead and fix that. So while that's turning away its little build in the background, I'm going to start to fix that by making this public. And structs need an empty initializer that's public, just to make sure that you can make them even if all they are is a library of functions. It's a good habit to get into, to start putting an empty initializer in there, even if you don't intend to initialize it with any constants or variables. All right, so let's save that. Go back into here. If I run my build again, we should be able to, oh no, well, nothing will be imported at the moment, but so we'll still get build failures, but we can go ahead and just generate our Xcode project and fix that inside of there. So here's our project. Still got our same executable to switch to. Now we have our 3 targets in 3 different folders to work from. We have manager framework, a model framework that we're using, and in here, all we're going to have to do is import to do manager. And I'm just going to copy and paste that around. Because I believe it's needed in all 3 of these. Even if it's not, it's fine for it to be there for the purpose. I'm not going to go through and make sure it's explicit. So there's our build. It's running, and our server's up. So now we have 3 targets. So this is the point at which it gets fun. So we have a manager target that manages the information between code in Swift and our MySQL database. I have a model, and I have an API. So this is where I could go into sources, and I could add a new folder, and I could call this to-do web, right? And I could go back into here in our package, and I could add a target, and I could call it to-do web. And our web is also going to rely on the model and the manager. I'm sorry, the model and the manager. But unlike everything else, it doesn't rely on the API, and the API does not rely on it. And this is where I would save this, come back here, stop the tasks. I would go into here, and let me just change to sources, to do web, and I'm just going to touch main.swift. So we have an empty main.swift. I'm going to package clean, and we're going to regenerate an Xcode project. And there we have it. We have a main. So this is where I would go, and you would start to see some of the same things copied here, an HTTP server. And now you'll see that there's 2 targets up here to run. You can run your API, and you can run your website with your mustache routes and templates and things. And you can put that into kind of a state where your API and your website are completely separate from one another. They can be independently restarted, they can be independently rebuilt, and they can be independently worked on. In your products, you'll still have your 2 frameworks that you designed, you'll still have your website and your API that come out of there, and this makes life really simple. And now I can talk a little bit more, now that you kind of know how that's structured and how you set that up, about just how useful that is. So here I have a little bit of a bigger project. Now this is a client project, so I'm only going to be able to show you parts of it. But I define this project as chest of war. I have a website, an API, a cron job executable target. A target war chest is my library full of database interactions and useful functions that I use pretty much everywhere. And then I have a library of models. Now this does some management for websites and servers at its core. So you'll see the things that you would expect to see in a model. What's a client? Well, that has an ID and a name, and that's going to correspond to a MySQL database to an ID and a name, and it's going to run out. Cron job is basically has things that go through and update. It looks for down servers or checks live status codes, amongst other things, and this is every hour and every 24 hours. It does each of those, and that kind of loops around in the background doing things. I have a web target here that has different mustache templates. These are all basically mustache template handlers in their own file called VC, because that's essentially my view controller in this case. And then I have my web root that has all these lovely mustache templates in it, along with all the JavaScript, images, fonts, and CSS libraries that I am using to make the web front end. This has an API target that hasn't had a ton of work done to it yet, but it is independent and it does have the basic structure of it. But the real beauty of this is this. So I have my web target here, and I'll start that and run it. and I have my cron target here, and I will start that and run that as well. I have my API target, and I'll start that and see if it runs. I may have broke it the last time I was working. Okay, I didn't. So I have 3 targets running. I have an API running. I have cron running, which is doing nothing right now and won't for the first hour because my first job isn't scheduled until an hour from now. And I have a website which is running. So, and this is the real beauty of this. So I have this website running at 0008383, and that's where all those mustache templates and fun things come in, and I can log into that. Okay, and it'll log in here for me, and I have a dashboard that does things, and I have menus full of things and all that. So that website's running, right? And so is my cron. So let's say I need to work on cron. I decide that I don't want this third job to run. So I'm going to go up here to stop, and I'm going to stop my cron, and I'm going to comment that out, and I'm going to remove it from my array of jobs that I want to start. Now, while I'm doing this, note that it's not running in the background here, but the web and the API are. So the website that's still front-end facing, if I go ahead and refresh that, it's still chugging away. And I'm here working on cron, and I say, okay, cool, changes to cron, I like those, let's restart that. I can build that independently and get that going. Likewise, if I want to come up here and stop the website, I can. Website stops, but my API and my cron are still down here, in theory, running and doing what they do. I didn't have to take that down for updates. So I could go up here to my website and I could say, okay, maybe on display index, I decide that I want this to say just overview instead of main overview. And I'll go ahead and save that, and I'll come up here to my web target, and I'll just rebuild that and start that again. So now I have my web target running, and that's by itself. Now this really does a great job at separating things out. I have a web root, which is kind of, in theory, what you could call the view, where I have all my templates and their dependencies. I have a web target up here, and basically all of these are just mustache page handlers, but when they're built out as a view controller to a view, you have a nice library of view controllers. You have a library of models that you can import and use anywhere at any time. I have a library of interactions with the database that does all sorts of different things in the database. So this does everything in the database regarding what a domain would be and what a domain needs to be. And then any of my other targets can use those in a larger project. Now this helps me a lot with things like scaling the project. It helps me a lot with working on whatever component needs to be worked on. It's great for debugging because everything is separated into its little bucket of what it does. And it's wonderful at just generally keeping me organized if I want to add another team member to this and get it all up on GitHub. We don't have to all work on the same thing. I can package my models up into a framework and just drag it and drop it into iOS and start on an iOS target that uses the API that's independent. And this is where it really starts getting kind of wonderful when you see the full picture. So that is my presentation here. And the other thing you'll notice is that if we go into here, and I'll just kind of note this so you can see it. If you look in your build folder, either on the command line or here in our to-do, oh, it looks like we're not built, but because I wasn't using the custom directory. Let's go ahead and run this so you can see this. If you're not using Xcode and you're just using the Swift Package Manager, it's virtually the same. I mean, the project's organized the same, the package is organized the same. Let's say we don't have our Xcode project here and we just have our build. And we get a nice SQLite database, looks like there, full of everything. We get our debug folder, and that's going to have all our builds. But we still get our frameworks in here. We're still going to have our to-do API target. We're still going to have our to-do manager with all of its fun stuff in here. We're still going to have to-do web and its target in here. And so once you're built, you can start just in the same way. But all right, let's go back up to our project level, and we can .build debug to do API, and we can start that, and we can run it. And we could open another tab and .build debug to do web, and I could run that. Now that's going to end instantly because I didn't put anything in main, and likewise I could stop this and I could no hop, which is no hookup to terminal, .build debug, and we'll do to do API, and I will take the output and send it to dev null, so we're not making any extra files with the text output from our print statements. I will send standard out, or standard error into standard out, so that that just loops back into dev null and again doesn't print anything, and then I can run that in the background with ampersand, and if you hit enter, that should just start in the background, and it may or may not have, there it is. So it's got a process ID of 27209, and it is just running in the background of my computer. And it's just chugging away, and anytime I could likewise kill 27209 at the moment, and then it will not be running in the background. It'll just say that the last thing it did was polite quit request, which is sigterm, is the signal. So I hope you enjoyed all of that, and I believe at this time I will get Lucas to field any of the questions that anyone has. So bear with me for a moment while I'm waiting to see if there are any questions. I'll just talk briefly and close this. If you're looking for more examples of great code, github.com/perfect examples is a great place to look. It's a great collection of those. Perfect.org is always going to have all of your available documentation, links to all the different repositories, as well as perfect.ly, which you can get an invite to join the Slack channel if you're not already there. Everybody in there is real friendly and helpful. So it looks like we do have a question. When you have a dependency as a target, when you change the deps, does it automatically get rebuilt when you build and run the parent project? You're still going to have to, if you add a new, oh, I'm sorry, I think I understand that. Yes, it does get rebuilt. So when you rebuild and run the parent project, and you kind of saw me do that there. Let me pull up my project again over here. So if you saw me change when I went into display index and I changed the name of the overview, I'll do it again here, main overview. Let's say this relied on something in here, and I'll change this to, I'll just put a print statement in here. So print init, oops, sorry, there we go. And I think that's going to need that since it's on a single line. If you do rebuild that, it will actually compile and link the dependency framework as well. So if I just rebuilt the web target, even if it relies on this framework and I change something in there, yeah, it will rebuild. It will not reflect, so if, say I had my API running and I changed something in my underlying the way things interact with my database, that's not going to change in the API until you stop that, rebuild that, and run that as well. But it will, for the web target, it'll change as that compiles, even if my API is running in the background. Are there any other questions out there? Yeah, so if you do change, for example, the model, you do have to rebuild the API for that to be reflected in the API, but because it's a dependency, it'll automatically rebuild the framework. So it looks like we have no other questions coming out. Let me look at YouTube. I don't see any questions on YouTube or Slack, so I think we'll go ahead and end here. Again, I'm Ryan Kellens. If you enjoyed this, you can always connect with me on the Perfect Slack channel at RYMCall, that's RYMCOL, or on Twitter at the same username. Thank you very much for watching. I appreciate your time, and we'll see you next time.